Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 8, 2026, just yesterday. It introduces a new framework that allows a small model to match the reasoning performance of a much larger one, while invoking that large model for only about 1% of the total tokens, slashing costs by over 98%. The paper is titled RelayLLM, Efficient Reasoning via Collaborative Decoding. And as we'll see later, the way the model learns exactly when to ask for help is really impressive. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 plots average accuracy against the call ratio, which tracks the percentage of tokens generated by the expensive teacher model. The dashed gray line represents a standard random router, illustrating a linear trade-off between cost and performance. In contrast, the red star shows RelayLLM breaking this trend. It achieves nearly 50% accuracy using only about 1% of teacher tokens, yielding the 98.2% cost reduction highlighted by the red arrow. Well, Figure 2 breaks down exactly how this collaboration happens. On the left, the diagram shows the inference workflow where the small language model acts as the controller. When it hits a tricky reasoning step, it generates a special call token, requesting specific help from the expert. The large language model intervenes briefly to generate the next few tokens, and then the small model takes back control. On the right, the training logic uses difficulty-aware rewards to fine-tune this behavior. It defines distinct scenarios. For student-solvable queries in the first column, independence is heavily rewarded, but for teacher-dependent queries in the middle, failing to ask for help results in a penalty, effectively teaching the model when it truly needs assistance. So, having seen how the model learns to ask for help, Table 2 now investigates whether this behavior generalizes to completely new domains. The authors tested the system on general reasoning benchmarks like MMLU Pro, despite training it exclusively on math problems. If we look at the 1.7 billion parameter model in the middle section, RelayLLM clearly outperforms the standard baselines. On MMLU Pro specifically, it reaches about 59% accuracy, jumping nearly 10 points ahead of the GRPO baseline seen just above it. Alright, while the previous results showed generalization, Table 1 provides the detailed breakdown for the 6 core reasoning benchmarks, such as Minerva and GSM-8K. Focusing on the QN3 1.7 billion models in the middle panel, the difficulty-aware RelayLLM achieves an average accuracy of roughly 49.5%. This score significantly outperforms the CITER baseline and recovers much of the performance gap toward the large teacher model shown at the bottom. Crucially, the final column reveals it does this with extreme efficiency, calling the expert for just over 1% of the generated tokens. Okay, having established the main performance gains, Table 3 dissects exactly which components drive that efficiency. The top row lists the full RelayLLM configuration, with its optimal 1.07% call ratio. Interestingly, the second row shows that, without data filtering, the call ratio triples to 3.3% as the model wastes effort on unsolvable problems. Moving down to the third row, removing the independence incentive causes calls to spike even further to over 4%, confirming that specifically rewarding self-reliance is key to keeping costs low. So, while Table 3 focused on efficiency, Figure 3 investigates the impact of teacher size. The blue line tracks the 1.7 billion parameter student. Performance climbs as the teacher grows, peaking at the 8 billion mark, which matches the training setup. Interestingly, the far right shows that switching to a massive 14 billion model actually hurts accuracy slightly, due to mismatch. Meanwhile, on the far left, even a tiny 0.6 billion teacher provides a lift over having no help at all. Wrapping up, RelayLLM proves that large models serve best as on-demand experts, rather than general fallback options. By teaching small models to strategically ask for help, the framework achieves high reasoning performance with a 98% reduction in compute costs. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.